Take your seats. There's a few ones in the front here. That's free. There's a bit more free seats right around here, right in the very front. Don't be shy. Just come in. Hello. Thanks for coming. I hope you enjoyed the conference so far. In this talk, I'd like to introduce the notion of UI engineering. And that means we would like to apply the same aspiration that we have for the back-end side also to the front-end side. We would like to apply engineering principles to the UI construction. Who in the room is somehow creating user interfaces? Oh, thank you. That was also the possibility to give me what is 100% in that room. Awesome. For calibration. Now, who would consider himself a UI engineer already? Oh, that's only 10%, 20%, and they're kind of shy, the hands. Okay. We'll see how that turns out in the course of the talk. When I coined the title of that talk, I was thinking about UI engineer is a term that you rarely find in a job description, that you rarely find on a resume, rarely find on a business card if you have that. So why is that? Right? That was my puzzling. And then when preparing the talk, I thought, there's two meanings of this, the missing profession. It's the job description is not there, but also we are kind of missing professionalism when creating user interfaces. Creating user interfaces is very often done by hooking stuff together. What's there, what the technology gives us, we just throw it together. And that is missing professionalism. Also, thinking a bit beyond only the construction, right? And we would come to that at the very end of the talk, with a call to action, as promised. My name is Dirk König. I work for Canoe in Basel, Switzerland, where we do quite a lot of UI engineering, 50 engineers so. And if at the end of the talk you would like to know more about UI engineering, we are looking for UI engineers all the time. Who is from Antwerp? Who is local? Hey, like 30%, awesome. And if I'll play you a video about a UI that we have engineered together with Oracle and Nevis. And if you recognize what that is, if you recognize the place, please shout into the room, right? I'm gonna show you that one. I have to show this since we're in Antwerp anyway, so where are we? Here we go. Here we go. So is that visible? Yeah, a bit blurry. What you see is an application that shows a container yard. Right? There's like container shipments on ships, on vessels. Yeah, first there's a 2D view where you see it from above, and the coloring is the various containers and where they go to, their point of discharge, as it's called. And then we change the view into a 3D view, whereas the UI construction, the structure of the UI is 100% the same, and only the visualization changes. We have switched from the 2D to the 3D world. And we're executing a so-called work plan. That means there's planning how to stack these containers for the least amount of handling when it goes on and off the ship. This is done with JavaFX 3D, which is awesome and cool. And in Java 8, you get JavaFX 8, and it has awesome 3D support. This was showcased for Java 1 last year, and developed together with Oracle for the 3D visualization, and with Nevis, the world market leader for container terminal software, and they have brought in the whole business logic. And this application runs on the server. This is a server-side application. All the business logic, not only business logic, also the application logic is on the server, only visualization is on the client. And what Canoe has contributed is the structure for getting from the server side to the client side, getting that in sync. Later we have open source that library that we have developed for that. Yep, that's pretty much it. Anybody from Antwerp who has recognized the container yard? Not surprisingly, that's the container yard of Antwerp, which is by size the largest container yard in the world. This is what we're currently aiming at. We're not aiming for a few websites with some forms and so on. We are looking for the best possible user experience that you can get. So here you go. Back to the presentation. This is what you can do. Now, what kind of considerations do we have as UI engineers? What knowledge do we need to have? What's the knowledge that we are looking for when we employ UI engineers? And what is UI engineering, what is similar in UI engineering applied to normal software engineering? Well, let's have a look. This is a mind map that you will find on the map, that you'll also find in the slides the public URL for that. And we can actually go to the web. It has a pretty nice UI, actually. So let's look at it. And I'm now playing it live on the web, so I hope it works. I hope the Wi-Fi is good enough. So what makes a UI engineer? How's that called? And there's lots of stuff that you need to know as an UI engineer. And this is by no means complete. Right? We would like to employ the very same aspects in UI engineering as we have in other parts of software engineering. First of all, separation of concerns. Our concerns when creating UI is separating content from visualization. And also have a separate concern about how we'd like to interact with the system, and that results in a certain kind of workflow. Right? With these various parts and their responsibilities and their collaboration comes dependencies between these parts. And as always, this is the usual mantra for software engineering. We would like to have the lowest possible coupling between our components and the highest possible coherence. And when there are dependencies between the various components, we would like to express the semantic dependencies as syntactic dependencies, meaning that if we have a component that has somehow an influence to the other component, we would like to have it in an IDE such that we can click on it and move to the other place. We can go find usages and come to the other part, right? Nothing's worse, and it often happens in UI engineering, in UI, that you somehow in your head need to know lots and tons of stuff that are kind of related in order to get your job done. Right? This is what we'd like to avoid. We'd like to express semantic dependencies as syntactic dependencies. That's all plain software engineering work. Now, what kind of knowledge do you need to acquire? If your aspiration is, I'd like to become a UI engineer, what should you learn? Well, first of all, it goes without saying, you need to know the technology, right? This is normally where it stops. People know certain kind of visualization technologies. This is where it starts, not where it stops. You need to know the respective standards, visualization standards, especially the patterns, and understand the patterns and when they apply and what the resulting context is. I'm pretty sure everybody knows model view controller. I don't even ask. But there's more: presentation model, model view presenter, model view view model, passive views, event bus, and they have some of them have very limited applicability, but some are very strong and give you the best bang for the buck. I'll talk a little bit more later about presentation model and event bus. And then there is user guides. There is, UI guides and user experience guides from Microsoft, from Apple, and from others. It's very good to look at those. Especially the Microsoft one is better than you would expect. Even as an engineer, especially as an engineer constructing user interfaces, you need to know something about graphic design. Right? That you cannot avoid it. It is, if you're an engineer, you need to know your engine, right? What engine are you deploying? And even an engineer who constructs a car needs to know something about the driver. Right? If you're constructing a dashboard in a car, you need to know, oh, it's a bipedal driver. He can brake and how he's operating the pedals and how he's steering, how he's touching all the other devices. You need to know something about your user, and here as well. The psychology behind this, how you recognize things, how people look for certain information, this is something that you have to learn. How you compose things on a screen, there's a few rules that you have to apply. Layouting is important. And then there's more, like colors and typography, okay. But there's more and more trends. For example, the Microsoft User Experience Guide is a little bit outdated now because there's new trends in what people expect from user interface, from a good user interface, with the advance of metro design from the latest Windows versions, but also iOS 7, these flat design things. You have to know the trends, and also other resources. If I'm not very good in creating that stuff, if I'm not so innovative, right? Where can I borrow? Steal. Borrow. Where can I borrow? You need to know the resources. That's important. What's the saying? The secret behind creativity is knowing how to hide your sources. Good. And of course, you need to know the tools, especially if you're in the UI area, these wireframing mockupping tools. IDE goes without saying. Visual building, yes. You need to know where they apply and where they don't. But that's something that's usually missing for the engineers. Engineers think they only need to know the wiring behind. No, you also need to know how you paint, right? And at least one of the painting tools you need to know, you need to master. If you're 2D, if you're in the 3D world like I am, you need to know you need to master at least one of the 3D modeling tools. That's important. And every now and then I see people saying, I'm an engineer, I'm not, I don't do that painting stuff, I'm not good at that. Well, you should give it a try. It's not so difficult. Now, this was the one part. And then there is a huge list of considerations that we have to think about as engineers when constructing user interfaces. And I'll only give you an overview. This is by no means complete. And I do that rather quickly. Correctness. Right? Correctness and testing and consistency and concurrency is all about correctness. We would like to display the right data, correct data, up-to-date data. You can have the finest backend in the world. If the UI displays outdated data or inconsistent or incorrect data, it's all gone. All the effort was for nothing if you display the wrong data. User interaction design, especially important. So how often have I seen, my shoulders drag like so. How often have I seen user interfaces from engineers, but not necessarily, certainly not UI engineers. They say, well, we have it all in the database. Let's construct the UI kind of automatically from the database. Who has heard that before? Okay, yeah, 30%. Okay. This leads to a totally unusable UI and your users will hate you for that. Most often that's in what's then called enterprise applications. Right? I'd like to quote Adam Bean on that. He says, it's an enterprise application if the UI sucks. No longer, because we can do enterprise applications, and an enterprise application is an application that runs on the server with a really good UI, as you have seen in that video. When it comes to interaction, you have to think about what kind of interaction is synchronous on the UI. Keep that as short as little as possible, and how to do asynchronous work, asynchronous interactions. And you have to guide your user through the work that he has to do. And there's kind of two main traits in that. And the one is you're providing kind of a wizard. Then you need to know the persona of your user. If that is a user that uses your system once a week, a wizard is okay, right? Because a wizard is telling the user, hey man, I'm smarter than you are. You better follow me. That's a wizard, yeah, that's fine. But never, 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 never do a wizard for an expert user who is using your system from morning to evening all day long. This is the worst thing you can do. You will annoy your user. The user is smarter than you are. And for those users, you make a system that uses direct manipulation. Whatever he's doing has an immediate effect on his result. For that, you need to have instant updates. Whatever he is doing does an instant update. And not only on his machine, but to the whole model that is possibly worked on concurrently in collaboration with other experts. For this, you have to give the user hints for how to operate your system. Right? All kinds of stuff that, is it enabled, disabled, does it have validation errors, all that stuff. It's even, the list is 3 times as long as that. And you have to provide them a context. Where am I? People are distracted, people get interruptions, and when they return, they need to know. It can be by containment, like you have a tapped pane, and tapped pane automatically gives you some kind of context. But you can also have like breadcrumbs and bookmarks and so on. You have to think about context. What kind of context is the user working in? Software-wise, but also the surrounding. Is he talking to some other customer while he is operating that system? Is that kind of kiosk system that you do like so? Or is an expert working in the cellar, right, in the basement, on his own? It makes a difference. Performance, and I would even more say responsiveness. What kind of responsiveness do we expect your system to have? Now it gets more and more into engineering, right? Especially latency. It's important. How would I like to distribute this? What kind of channels do I have? Is that desktop thing? Is it web? Is it mobile? And so on. The distribution has very serious influence on the privacy that you can guarantee to your users. It's your responsibility as an engineer to guarantee the privacy that needs to be guaranteed. Right? It is your obligation to do that. Nobody else. The user cannot tell. He don't have the knowledge about it. And it may not even be in the written requirements. And one of the important things here is when the user uses your system, he has a mental model. You have to think about that. He has some idea about how the system works. You see that pretty often he's calling your system he or she. Or so. He now knows that so-and-so. He has some kind of an impersonation of what you have done. Isn't that cool? I like that all the time. So anyway, you have to think in his terms and not in your terms. Your terms may be like database tables and so on, but his terms is I'd like to have that activity done. I'd like to have that, the user registered or whatever. This is the overview. But most of all, the biggest consideration of all, the biggest requirement that you should have is common sense. I mean, this cannot be replaced by any other knowledge. Okay. Thank you. You can look at this on the web, and I will open it for editing such that you can add your own observations to that. So let's go back to the presentation. Now, with all these considerations, question is, haven't we fixed it already? I mean, we have model view controller. This should have fixed it once and forever. Sorry, no. Model view controller is not even a pattern in my eyes. Model view controller is like a general idea how you'd like to distribute responsibilities. But what you mean by model view controller is, this is watered down meanwhile to an extent that it is totally empty. It's totally void. Right? I have seen systems that claim to be model view controller that have no model. That's pretty often, actually, and on the web you see that very often. I have certainly seen a number of them that have no views, and most of them have no controller. If you have model view view model from this .NET thing, model view view model, there's no controller in there. Model view presenter, there's no controller in there, right? So they don't have. I ask myself, where do I put my logic? Well, what's application logic? Where do I put it in that system? And worse, when people say model view controller, and I've seen systems that have no model, no view, no controller, and were model view controller anyway. So, and then people have totally different notions when they say model view controller for good reasons, and we'll have a look at that. So you can have model view controller on a system level, on an enterprise level, if you want, saying my data model is what's in my corporate data sources, could be many databases, right? And then the view onto this large amount of data are my applications that I have, of course, right? And the kind of controller that I have on that data is my transactions or my Corba services, whatever kind of EJBs and any kind of other services. Are we getting a free drink or something? Okay. Now, and each of these have model view controller in them, right? The data model, the database, has views, database views, right? And they have controllers like store procedures and triggers and so on. And of course the tables, which is the model. And the services, again, have model view controller in them. But for today, we'd like to open the application. The application itself has model view controller. And if you split that up, if you can zooming in into the application, there's an object model, and then there's some kind of presentation, and there's a workflow attached to it, which is kind of the controller. Now, if again we're zooming into the presentation itself has widgets, which are views, listeners, kind of controller stuff, swing, JavaFX, and all the other listeners that we have on the web. But you can have a very special model for your presentation, and this is called the presentation model, not surprisingly. And again, you could, for example, have a widget being contained of other, again with MVC, like if you have a widget like a table has a table model, we call that a widget model. Right? It's only very contained to only that widget. It's not visible to the outside. It has a visual representation, how it's rendered, and it has maybe editors like the controllers and editor, how you work in that. But we're not normally talking about this presentation model thing over here in the next slides. So that is the presentation model thing. And for example, the model view model pattern is quite obviously an attempt. It is talking about this kind of model, about this kind of view, and the view model then is probably something like that, but I'm not sure. And if you're kind of making one pattern out of that, you should be on one level. If you're kind of mixing the levels, that leads to confusion. At least I'm confused by that pattern. Now, we're coming to the practical part, right? We have model view and controller. Is that enough? That's only the structure. We haven't said anything yet about the real responsibilities, the dependencies, who knows each other, who knows whom, right? And we've only seen one instantiation of that and not many views and many controllers and how those play together. So saying model view controller is certainly not enough for your system. If you're designing a system for yourself, you need to have more, because otherwise, and if you follow the typical tutorials that you have for technologies, right, for UI toolkits, they are made such that you end up in the following situation. A model is somehow, a view is registered for a model, let's put it that way. It's an observer, therefore the dashed line. It is known by instance, but not known by type. But the view is calling back into the model, and this is known by type, therefore the strong one. The view knows its controllers, and the controller reads and writes to the model. So good, so far so good, right? Unless, when you have a change in the model, there may be a second view that needs to be updated as well from the controller. The view has changed. Let's say the view is a text field, and the text field needs to be saved or anything. It has changed, so the controller puts in the new value in the model, but also needs to update the status bar, some other view, right? It needs to update it. So it needs to update, so it's maybe updating the view directly whenever a view reaches out to a model, whenever a controller reaches out to a view, all bets are off. If you allow that, all bets are off, right? Because then this change may trigger some other controller, and the controller needs to update the other model, and the model may have a second response to some other one, and then the bind storm goes on. And this is a maintenance nightmare, and you will end up in a situation where you don't have any of the so-called ilities, right? The maintainability and the extensibility and sustainability, all those. Right? This is a nightmare. But it's kind of unavoidable to end up in this situation if you follow the typical tutorials. The tutorials are there to explain the API of the toolkits. And they're absolutely fine for that. It's not a tutorial how to construct a UI. If you have an architecture, it's not enough to define the structure. You also have to say something about the concepts, the rules that apply, the principles by which the UI is built and is working. You see this little dolphin over there? I'll give you a short introduction into open source library Apache 2 license called OpenDolphin, where we from GNU have tried to capture, and I guess it was quite kind of successful, capture the experience from over 10 years. It's certainly worth more than 100 person years, what is in there, even though it's a very small one. And the structure is a model view controller structure, not surprising, but what is even more important are the rules that apply to that structure. Now here's model view controller, as you would expect it, right? So only the model is kind of split in two halves, and they are automatically synchronized by the dolphin. It is a shared presentation model that the view and the controller share, but the controller is only working on that part of the model. Those are synchronized, and the view is totally passively binding against that part of the model. It's the same model for both. Now the controller, here's the first rule, responsibility. Controller is responsible for the what to display. He's responsible for the content, what to display. And the view is responsible for the how to display, right? The view is, pretty, but unintelligent, right? It's a Barbie view. Now that you have, as soon as you have that, you can split it here even into two different processes and on totally different machines if you want. Have the client here, have the server here. You can run it in one VM or you can run it in two different VMs. That looks interesting. Now, here's a short wrap-up of the concepts and certainly not a complete one. First of all, no view knows any other view. First rule. There can be exceptions to that rule for composed views, like a big view that is composed of lots of small ones, which is then known by the parent, but it has no actionable consequence there. No controller knows any view, and we can actually assure that, because I go back like this. This part here, the client part, compiles without that part, right? This cannot possibly reach out to a controller because it's not even on the class path when compiling. And it's certainly not in the same VM when running. And this part compiles without the views. No controller can accidentally, just for now, reach out to the status bar and update it. No, he cannot possibly. But the only thing that he can do is giving the model the information that now something should be displayed in the status bar. Oh, sorry. Yeah, okay, here we go. Never go back. No controller knows any view. There's no exception to this rule. A view can only ping the controller. So if it was a typical API call, like in a listener that you have in Swing or JavaFX or so, you know the source who has triggered you, right? But not so in the OpenDolphin system. The view can only say, well, I have a button. I somehow have to say what should happen when the button is clicked. And the only thing that we can say is, we'd like to ping the submit action in that controller. Right? That's it. That's all you can do. We can guarantee, now it comes. It's effect from the system, right? From that system, if you have it so. Now you can have guarantees. And one guarantee is that whatever you do to a view always happens in the UI thread. Very important for consistent and correct visualization. We can guarantee this, right? You could spawn your own thread, and you should never do this in the first place. But yeah, then you're off. Then you're on your own. But as long as you're just working with the views, everything you do is in the UI thread. Controllers are always, 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 always. There's no exception to this rule outside the UI thread. By the way, there's no exception to this rule. There's no exception to this rule. Controllers are always outside the UI thread. If you have ever done any work in typical event-driven system with UI threads, you will love this, right? Because normally what you have is, okay, it's only a short action, so I do this inside the UI thread if you think about it at all. And then, okay, now it may get a little longer. I have to fetch something from the web, have some service, could take a little longer. I'll do it outside the UI thread. But now I have to update the view because that controller knows the view. But this must be inside the UI thread. And then you end up with this nesting of platform run later or Swing utilities run later and run outside and run later and run outside and run later. Ever seen that before? If you do it correctly, it is a mess with this kind of nesting. It's very difficult to test. But we can make sure that every controller always runs outside the UI thread. It may even run on a different machine. And all the communication, always, without exception, is asynchronous. We get callbacks and so on. Typical asynchronous behavior. And I give you a short example of independent views, how that looks like. With OpenDolphin comes like 25 or 30 or so demos, and here's one of the demos. So it's kind of from the finance industry. It's actually requirements from a real customer. So you're managing portfolios. Here's a balanced portfolio. There's a growth portfolio, what have you. You see this little animation? So the view is there immediately, but kind of transparent. But only when the data is available, it materializes. Right? It's an interesting. We talked about psychology. It's an interesting, much better visualization for now is the data there. Now you can start working better than busy component or spinning something or so, right? Now, this is cool. Now it is about instant updates. We're talking about direct manipulation here. That's an expert's view. When we change the label for that portfolio, this label must change, this label must change, and any other visualization of that label must change immediately. So if I say X, 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 see that? Make it back, 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 X, 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 back, 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 back. Or if I just replace it by any other thing, like say DevOps, right? Immediate change all over the place. And even if there was a second line showing the same information, it would also update immediately. Because there is a model behind it, and they're binding to the model, and the models are synchronized automatically. But even more, let's say I'm creating a new so-called financial instrument. Clicking on plus, and there's a new change me, and this is updated as well. It goes without saying that this table and this chart know nothing about each other. I can, at any time, remove one of those without touching the other. I can create a new one without touching the existing ones. I can change one without having the fear that I break something in the existing ones. Right? Important. Even if I change this one. Now, this should possibly be Canoe, of course, right? So Canoe shares. Enter, right? This view and this selection model knows nothing about that over there. As soon as you have a system where this selection model over here in the listener knows anything about that one, your position is not so good, let's say. But even, have you seen the total being updated? The total over here, now it's 110, and it's also over here, 110. Goes without saying that this is all absolutely independent. All the views are totally independent. Even the plus button knows nothing about that table. We go as far as you can go, right? The plus button could be, anyway, it would work without the table. You could have the plus button and it would show over here, right? It's only the visual representation looks as if it would be connected to it, but it isn't really. If on the server side I decide there should now be a new instrument, because that's our standard instrument, always the best instrument that we have, and you must have it, then the server-side logic could apply it, and the client would happily display it. The client is dump. He just displays what's there. There's kind of a relational model behind that. I could go much further, but for today, we leave it like so. That's the construction of a single UI. Now, what if we have multiple UIs? Then we need some kind of real server that was in the back. So I'm starting a server. That's Java Enterprise, in this case, Grails server. And we will have, if it has started, yep, here it is started. We will have two clients. This also demos from the Open Dolphin open source project, and which is kind of, I call it a Tacho. This is, I don't know the exact English word really, displaying a velocity. It's like in a dashboard. And the second one, which runs in a totally separate UI. Right? It's totally different JVM. This one and this one. And now, one is changing the velocity over here, zip, and the other one is changing at exactly the same time and same speed. Well, maybe not so surprising. As I recognize from your response. But now it comes, right? If you have a correct, a very good construction of your UI, you're totally independent also of your channel, of your distribution channel. So let's put that over there. If I have that, is that here? Okay. And this is the Tahoe page. Let's show the Tahoe page. Is that visible over there? Yeah, kind of. Now have the other Java. This is JavaFX, really. Bless you. Now, the thing is, well, I can change any one of those. It has not yet an effect on the web, right? It is just going like so. But now I can say, well, on the web, I would also like to have the update, right? 65. And I can change any time. And it could be on my mobile device. And I can read the orientation from my mobile device and put it on there. And how's that done? I mean, is that now WebSockets, or is that Comedy, or Faisalcast, or Speedy, or HTTP post, which goes through every firewall and every proxy, and every server knows how to handle this? And unbelievable, it's just plain HTTP post. Doing this like so, and to the back. If you have a good modeling of your system, a good architecture, solid UI engineering, you can accommodate use cases that you haven't even foreseen. That's the story here. Was it visible? You're kind of so quiet. It's okay, it's okay. Good. Let's go back to the presentation here. Good. So what we have seen, the collaboration between various views. How is that done? How is it working? Of course, you would like to see how that is working. Now, this was the single version. Now, what if we have two of them? Two of them is just they're beside each other, and on the server side, they share information over an event bus. Here we have presentation model, here we have event bus. Two of the patterns applied in the system. There are systems that are mainly focused on event bus, like NetBeans, for example, is mainly constructed over an event bus, the whole system. Others, if I'm not mistaken, IntelliJ IDEA has mainly a presentation model in it. But both of them have a combination. It's only very focused more, right? So NetBeans focuses more on the event bus. Others focus more on the presentation model. In the end, you always see both. It's a question where you apply which one. Now, if you have this, then it's this is totally different clients, right? They can use the same technology, but they could just as well use different technologies for display. It's only a matter how you bind against the model. Right? How are you binding against this model? And the interesting part is the code here, how a desktop JavaFX, for example, binds against the model, looks almost identical to Dolphin.js, where you use JavaScript to bind against the model. It looks almost identical. Here you make a JavaFX UI, and then you use the binding, bind against it, property binder. And here you have an HTML view, and then you have a little bit of JavaScript saying, I'd like to bind. When this happens, I'd like to have the value update on the respective attribute. It is, if you look into the code, looks almost the same. Would like to see some code? Yes, okay. We have 10 minutes left. I can show you some code, right? Here we go. Let's go into the CRUD view. Create, read, update, delete view, and make that big. Right? Oops. No, I should have used the other view. Sorry. The shared Tahoe view. It's easier because it only has one thing. So what you have is you have this gauge, which is this radial thing showing information made by Gerrit Grünwald. And here is the view. That's the full view. Yeah, it's a little bit blurry for you. There's a scene, and in the scene there's a border pane, and there's a center and a bottom, and in the center there's a node with a gauge inside. And below this is a slider. That was it. That's the full description of the UI, the static description. Now, how you bind? Here is the binding. This is Groovy, okay? Make this a little bit bigger. If it was Java, you would. The very same is available for Java, but then you have to write it as bind speed dot of car. You get the point, right? So dot to so and so. Now this is Groovy. It's okay like so. The speed of the car to the value of the gauge. So whenever the speed changes, the gauge changes its value. That's it. That's all there is. For the slider, we make a distinction whether the slider is currently pressed. If it's currently pressed, we are only changing it to our own value and not to the value that comes from the server. And that was pretty much it. Now, if you go to the web page over here and say, please show me the code. That's all in the demos of OpenDolphin. And here's the, well, this is really a little bit difficult to see. The JavaScript code, which has, we're clicking on the button, and the button does then a long polling. But here is the binding. Above that, there's HTML with the respective component in it. But here we say the speed attribute on value change, set the value on the gauge. That's all you need to do. Resulting in a construction that even allows me, who has almost no knowledge about JavaScript, for writing this kind of application, right? Because it's everything you do, connecting to your Dolphin, do the binding, all the rest happens on the server. And this is Java or Groovy. And it's up to you what you want to do with it. So, but of course, this talk is not so much about OpenDolphin, it is about UI engineering. And this was only an example. Keynote. Here we go. We come to the important part. Then, yes, you can multi-channel things. Okay. Here you find more information about OpenDolphin and about me and whatever. Now, here comes the call to action. And the call to action is that you as an engineer, as now becoming UI engineer, you have some obligations. And especially the obligation that you have to think for yourself, right? Especially when it comes to the distribution channels and the privacy of your users, which is a consideration that is rarely reflected in the requirements. Have you ever considered, did you ever ask yourself why there are so many people who would like to enforce the notion, enforce the mantra that everything must happen in the browser, right? Everything should happen in the browser. And they're investing heavily such that everything should happen in the browser, right? They're investing heavily and give you everything for free, only to make you write your code in your browser. And that's absolutely fine for a huge number of applications, but as soon as privacy is concerned, not so much, right? Now here's a true story, kind of a sad story actually. So recently, for a private investor who called me in, and he said, I should review a project where he would like to invest in, whether that is okay or not. Well, I signed an NDA, and I cannot really tell much detail about it. But what I can tell is, It was a web application, and it was dealing with privacy-concerned data, and privacy-concerned in a way that I'm absolutely sure there are people on this planet who would pay a lot of money to get to their data, right? That kind of privacy. And the engineers did it with web technology, and mostly JavaScript-based. And they had the idea that it would be really good, because there was addresses in there, to display these addresses on that web page with Google Maps. I'm not quite sure whether you know how that works, Google Maps, right? But it means you have to fetch the JavaScript from the Google server. It is disallowed by the license that you fetch it yourself and scrutinize it and validate it and look at it and then deliver it from your own server. It's disallowed. You're not allowed to do that. One thing for technical reasons, right? But what that means is you draw in code that happens inside your code, that is then executed inside your code. It has full access to everything on your page. It has full access to everything you are doing, right? You're kind of dynamically assembling the view from pieces that you have no control over, right? And in a way, it's a self-modifying code. Now, if I would go to one of my customers and say, well, I have this new idea. We're making the system like so. We're dynamically assembling this UI with self-modifying code loaded from unreliable source. How's that? Isn't that cool? They would say, well, thank you, Mr. Koenig. You don't have to come tomorrow. And I have a free day. But if I say, well, let's do Ajax, and they say, yeah, go for it. So I would claim, given the latest revelations that you probably have heard, and given all the stuff that I've seen on the web, by the way, there's always talks in these conferences saying, hey, here's what you can do on the web. Now you can do everything on the web. Yes, yes, yes. Right. And that is scary. Now, you as an engineer have the responsibility to consider whether the privacy of what you're displaying in the web is really of concern or not. If it's not a concern, fine, go with it. If it is of concern, I would urge you to, I don't know, you have to do what you have to do, right? Because this is the final mantra. Think for yourself and question authority, even mine. Mine is fine, you can always follow me. But otherwise, you have to think for yourself. Think about the architecture that you're using, right? Especially on the web. And my personal opinion is everything that is displayed in a browser, no matter what kind of protocol you have in behind, if it's displayed in the browser, it's inherently unsafe. There are ways to make it safer a little bit, but I haven't seen a way yet to make it really safe. Inside an organization, if it's not touched from the outside, it's a bit of a different story than when it comes to the outside, but it is inherently unsafe. And think for yourself, why you are getting so much for free? Who's investing for what reason to make you making all your code on the browser? Somebody has an interest in that information. Now, it's a little bit bad to leave you on that sad note, right? But it may have a longer lasting effect if I do. Do you have any questions or remarks or notes about that? Yes, please.
Can you tell something about state on the server and scalability?
Oh, the question was, can I tell something about state on the server and scalability? Well, yes, you know this one. I like that one. Thank you. Thank you much. So the common mantra is, I'll put it in that context. You may have thought about another context. I'll touch that as well. But now the typical mantra is, the server should be totally stateless for the sake of scalability. If I would have an interest in your data, I would very loudly say that statement, right? Because then your state is either in the browser or it's in the protocol over the web. Tapping into what is in the protocol is a bit difficult, but not undoable, right? Tapping what is in the browser is absolutely easy, even I can do that. Tapping what is on the server is difficult. It's not undoable, but it's difficult. You have to kind of put a rootkit in the browser to do that. So any state that you have on the browser, on the server side, is safer than everything that you put outside, be it on the protocol level or be it in the display in the browser. So what we do, the Open approach, is to have as little information going outside as possible. We are not downloading, we are downloading only what is actually visible, right? If you have a list of 100,000 entries, we display only the first 25 that you're seeing anyway, and a little bit of prefetch. And if you start scrolling, we are showing the other ones. But like lazy loading, typical thing. This is a typical result of that architecture, right? Keeping as much state as possible on the server side. Does it require state on the server side? Yes, it does. Because an application is running on the server side, application is modeling data, and it must have the data on the server side. How does that relate to scalability? Does that relate to applications of Facebook and Google style? No. If you are doing Facebook, don't do that, right? Sorry, that can be misunderstood. OpenDolphin is kind of if you have server state, that's absolutely fine for all kinds of enterprise applications, I would say, right? It's not the right structure for massive scaling to end users that do just anything, right? That if you have millions of users, probably not a good idea. As compared to other technologies that are typically used inside the companies, organizations, it's actually not so much, the memory footprint is not as big as you would assume, because even on client side and on server side, because there's some state, right? And you need session affinity for your browser, for your server cluster and so on. Granted. But the amount of memory that you need is not so big, because what you model is the relevant state of the UI. And the relevant state is only what is visible. Now, what is visible has an upper limit. I mean, you cannot visualize more than you have pixels on the screen. Typically less than you have pixels on the screen. It's typically a few kilobytes that you have, right? If you do it really wrong, you may end up with a megabyte. But when we do the scaling for the web servers, we usually have the outcome that memory is not the bottleneck for that. So there's always enough memory for all the users, because most of the enterprise applications have like 500 concurrent users on one server or so. That's typically not the bottleneck. Does that answer the question, kind of? Okay, thanks a lot, and I'm available throughout the whole day, and I wish you a lot of fun with the other talks. Thank you.